Dear students, I hope you are all well and studying in your home. Last week, in the chapter Atomic Structure and Chemical Bonding, we started reading about chemical bonding and see the formation of electrovalent or ionic compounds and bonds and their properties. Today, we will read about the covalent bond according to Lewis' concept. So first, we go through the definition and formation of a covalent bond. So first, we understand that how it is differ from ionic bond. The formation of an ionic bond is possible only when there is a large difference in the electronegativities of the combining compounds. No ionic bonding is possible when the atoms of similar electron negativities combine. Therefore, the electron transfer theory, as discussed earlier by us, could not explain the bonding of in the molecules such as hydrogen, nitrogen, oxygen, chlorine, methane, etc. In order to explain the bonding in such molecules, G. N. Lewis suggested a different type of bonding known as covalent bonding. Okay, so where there is no much difference in electronegativities, how the bond is formed. So Lewis suggested that two atoms having similar or almost similar electronegativities can achieve a similar valence shell configuration 2 or 8 electrons in the outermost shell by mutual sharing of electrons between them. So what is the difference between ionic and covalent bond? Here you can see that mutual sharing of electrons are occur, where in ionic bond only one atom will be share the electron. Okay, so that's the difference. During the formation of a covalent bond, the two combining atoms contribute equal number of electrons for sharing. The shared electrons be regarded as common to both the atoms, as shared pair of electrons is represented by dash. Okay, you can see further, and is responsible for holding the two atoms together. This shared pair contributes what is known as covalent bond. Okay, so very easy to understand this covalent bond or electron pair bond. Thus, a covalent bond may be defined as follows. The attractive force which comes into existence due to the mutual sharing of electrons between two atoms of similar electronegativity or having a small difference in electronegativities is a covalent bond. So this is the definition of covalent bond. Now, the number of electrons contributed by an atom to form covalent bond is called valency of that atom. It is also important. So there are two types of covalent bond are found, non-polar and polar. So first we read about the non-polar covalent bond. Electronegativity is the measure of tendency of atom to pull the shared pair of electrons toward its own side in a covalent bond. When a covalent bond is formed between two similar atoms having the same value of electronegativity, the pull of the two atoms on the shared pair is equal to the shared pair lies just in middle of the nuclei of the two atoms, as you see in figure 4.10. Okay, so here the electron pair will be occur in the just middle, okay, of these two atoms, and a non-polar covalent molecule, you can see it is, as you know, covalent bond is denoted by a dash. Okay, so try to understand it. Covalent union between two like atoms gives rise to the formation of a non-polar covalent bond having shared pair of electron just in the middle of two atoms. So you can see one paired electron from H and one from second hydrogen, it is denoted by uh, cross. Okay, and it is first one denoted by just dot, so they are mixed in the middle, you can see is here. Okay, after arrow. So this is a non-polar bond. Similarly, covalent union between two chlorine atoms give rise to non-polar bond. Okay, you can see. So there are some examples of non-polar molecules such as hydrogen, chlorine, oxygen, nitrogen, fluorine, and bromine. If you still have any confusion, you can understand by the term polar covalent bond. When a covalent bond is formed between two atoms of different electronegativities, the atom with a higher value of electronegativity tries to pull the shared paired of it to a greater extent. Okay, now we can understand that in first one, non-polar, both electronegativities of atoms are equal, but here one has more electronegativity and it tries to pull the shared pair of electrons. Okay, as a result of this, the shared pair of electron gets shifted toward the more electronegativities atom as shown in figure 4.11. So you can see, so as a result, you can see the more electronegative atom acquires a partial negative charge. Okay, and the less electronegative atom acquires a partial positive charge, as shown in figure. You can see B point here. Okay, so as you know that which carry electrons ultimately gain the negative charge. Okay, and who loses electrons ultimately contain a positive charge. The covalent bond thus develops a partial ionic character. Such a covalent bond is referred to as a polar covalent bond or partially ionic covalent bond. For example, hydrogen fluoride is a polar molecule. In hydrogen fluoride, the H-F bond or HF bond is a polar covalent bond due to unequal sharing of electrons between more electronegative fluorine and less electronegative hydrogen atoms. Now you can understand this type of bonding very easily. So the sharing of electrons between more electronegative and less electronegative atoms gives rise a dipole formation. Okay, you can see here the structure is formed of dipole. A dipole is represented by an arrow dash that points toward a negative partial charge. So if you see the example of hydrogen chloride bond formed here, okay, so you can see arrow because chlorine is more electronegative than hydrogen. So one arrow dash is represented here. Okay, you can see in some examples are given here that water, ammonia, methane, and carbon tetrachloride have polar bonds in their molecules. So some formation of hydrogen molecule is structure of chlorine molecule and some other structure as H2O, ammonia, carbon tetrachloride, methane molecule you can easily understand. If you have any difficulty to understand them, you can tell me. Okay. Now we see the multiple covalent bonds. As you know, the bond formed by sharing of one pair of electron is called single covalent bond. Okay, and it is represented by single dash. Same, the sharing of two pair of electrons is known as a double bond, and the sharing of three pair of electron is known as triple bond. So by this example, you can understand easily the formation of double bond and structure of oxygen molecule. The atomic number of oxygen is 8 and its electronic configuration is as follows. Okay, you can see easily here O and its atomic number is 8 and it is represented by 2 6 in electronic configuration. So oxygen atom has 6 electrons in its valence shell and needs two more electrons to achieve an octet. Okay, to acquire stable electronic configuration. Okay, it can do so by contributing two electrons during the formation of a covalent bond. So when two oxygen atoms approach each other, they contribute two electrons each from one of the two bond pairs. In the middle of in the molecule, each atom share two pair of electron and thus achieve an octet. By doing so, they get held together by a double covalent bond. The formation of two molecules is shown below. So electron dot structure, if you see that both has 6 electron and They just contribute, or you can say they pair their two electrons with each other and get the octant state.